Thanks for the opportunity. Now I will explain about Torrey graph and Dijkstra shortest path in graph.
Okay.
Okay, graphs are often used to represent an object and its relationship to other objects. The history of graph theory began when Swiss mathematician Leonhard Euler solved the Konigsberg bridge problem. The Konigsberg bridge problem is an old puzzle about the possibility of finding footpaths on 7 bridges that run along a branching river that crosses an island, but without crossing the bridge twice. As used in graph theory, the term graph does not refer to data charts, such as line graphs or bar graphs. Instead, it refers to a group of vertices, that is points or vertices, and edges or lines that connect vertices. When 2 vertices are joined more than one edge, the graph is called multigraph. Basically, graphs have components in the form of vertices and edges in the graph to form open graphs and closed graphs. Then form a number of trajectories and circuits. Then the graph theorem has been able to solve the question mark in solving the Konigsberg bridge puzzle and with the solution to the same problem.
Okay, good. Next.
This algorithm was discovered by Edgar W. Dijkstra and published in 1959 in a journal Numerische Mathematik entitled A Note on 2 Problems in Connections with Graphs. Dijkstra is one of the popular algorithm form variants in solving problems related to the optimization problem of finding the shortest path of a path that has a minimum length from vertex to z in a weighted graph. The weight is a positive number, so it cannot be passed by negative nodes. But if this happens, then the solution given is infinity. In the Dijkstra algorithm, the node is used because the Dijkstra algorithm uses directed graphs to determine the shortest route. This algorithm aims to find the shortest path based on the smallest weight from one point to another. For example, points represent buildings and lines represent roads. The Dijkstra algorithm calculates all the smallest possible weights of each point.
And then, how do you explain the logic of the Dijkstra algorithm?
This is the logical sequence of the Dijkstra algorithm. First, give a weight value, distance, for each point to another point, then set the value of 0 at the initial node and the infinite value with respect to other nodes not filled in. Second, set all nodes unfocused and set initial node as departure node. Third, from the departure number, consider the neighboring node that has not been touched and calculate the distance from the point of departure. For example, if the departure point A to B weighs a distance of 6 and from B to node C is 2, then the distance to C passes B to 6 plus 2 equals 8. If this distance is smaller than the previous distance, which has been previously recorded, delete old data, resave the distance data with the new distance. Fourth, when we finish considering each distance from the neighborhood node, mark the node that has been touched as touch node. Touch node will never be checked again. The distance saved is the last distance and the minimum weight. Fifth, set unexplored node with the smallest distance from the departure node as departure node afterwards and continue by returning to step 3. The next step is to make a calculation table, where this step is very important because this table will determine the overall calculation process. The calculation process with the table can be said to be true if the number of steps taken amounts to all points plus 1. For example, there are 6 points, then there are 7 steps taken. After completing the table, we get the value, distance, of all the connected points that have been passed from the starting point to the destination point.
Great, Ruth. I can't believe that you can explain it very well. Congrats.
Thank you so much, Professor.